So here I'm going to be doing exercise 4.2. So in this exercise, I'm asked to find the time of flight between two points. These 2 points are f1 is equals to 270 degrees, and the second one is 90 degrees. And we have measurements. The altitude at perigee is equals to 350 kilometers, and the altitude at apoapsis, so the most periapsis, is 1,206 kilometers. And so I'm given yes. Okay. So now I need to find the time of flight between these two angles. Now, the time of flight is calculated with the following formula: a cubed divided by mu times e minus e sine e. So first of all, we need to find e, right? Well, actually, not first of all. We need to find e, little e, and capital E. What is capital E? Well, capital E comes from here. What was it? 1 minus e, 1 plus e, square root of tangent of f divided by 2. So here I have e is equals to 2 times tangent power negative 1 of 1 minus e divided by 1 plus e, square root of tangent of f divided by 2. Yeah, and then of course we have to do it with both values. So I'm going to have an e1 at f1, and I'm going to have an e2. What's happening? Okay. No? What? Duplicate, move down. There we go. E2 and F2. Okay. Yes. All right. Um, and now, of course, we need to find E because we need it both in here and in here. How do we find E? Well, since we have the altitude and at perigee and apogee, we're going to find the radius at apogee, which is going to simply be the altitude, the radius at apoapsis, which is simply going to be the altitude at apoapsis plus the radius of the Earth, and the radius at periapsis, which is the altitude at periapsis plus the radius of the Earth. Okay, now that we have this, E is going to be equals to RA minus RP divided by RA plus RP. So this is my E. Yeah, and now we're gonna find everything. I can just solve it. So let's just check everything we have. By the way, when we're calculating the time of flight, we can do it in two different ways. So one way that I like, but it's slower and honestly not the greatest, is so this is 270 degrees, this is 90 degrees, is instead of since our formula, or the one that we're given really, it's T minus TP, so times the perigee, it means that we're doing the times it takes from perigee to this point here. So when we're calculating the times that it takes for it to go to 170, we're calculating this time here, not this time here. So, oops, let me erase it. There we go. So one way I do it is I usually find the entire period of the orbit, as this time here, get rid of this blue line along here, so all I get is this little piece here that is left, and then I add this second part here. However, when I find E1, which is when we have F1 of 270 degrees, I get an E that is less than 0, meaning that my time of flight will be something that actually means the entire orbit. Interesting enough, though, is given the symmetry at these 2 points of the orbit, if we cut an axis over here, the time that it takes for it to go from 0 to 90, the time it takes for it to go from 270 to 0, it's going to be the same. So really, we can just find the time that it takes for it to go from 90, from perigee to 90, so from 0 degrees to 90 degrees, and then just multiply it by 2. However, we want to do things correctly, and we're going to do it nicely. So um, a different way we can do it, and that's the way I would suggest, because that's the clean, elegant way to do it, is the time of flight that it takes between 2 points is going to be equals to square root of a cubed divided by mu times e2 minus e sine e2 minus, everything multiply here, minus e1 minus e sine e1. So yeah, you're starting from e1 and you're going to e2. This is all that you need to plug in there. And let me show you what we get. Let me cut it up. This is the final answer with a time that I divided by 60, because of course I got it in seconds. And so I get 46 minutes. Done here in minutes.